Have you ever wondered how solar farms are designed and engineered? These vast fields of gleaming panels are more than just a pretty sight. They're a testament to human ingenuity, harnessing the power of the sun to generate renewable energy for our ever-hungry power grids. But the journey from concept to reality is a complex one, involving diligent planning, rigorous assessments, and meticulous design. Now, let's dive into how these solar farms are actually brought to life. Choosing the right location is the first crucial step in the creation of a solar farm. Imagine you're on a quest. Your goal? To find the perfect piece of land for your solar farm. This isn't a search for any ordinary plot of land, oh no. You need a place that basks in the sun's glow, almost as if it's sunbathing, a place that's easy to reach even with hefty construction equipment in tow. Now, let's talk terrain. You're looking for flat land with no trees in sight. You don't want to be playing hide and seek with the sun, after all. And remember, a floodplain is a no-go. We don't want your solar panels swimming away, do we? Soil conditions are next on the list. Good soil can make construction easier and more cost-effective. It's a bit like trying to build a sandcastle. You wouldn't want your castle to crumble at the slightest touch, right? Now let's talk about the grid. Your site should be close to it, or at least have the potential to connect to it. Sure, there are off-grid solar farms that rely on advanced battery storage systems, but let's keep things simple for now. And while we're on the subject of location, let's be respectful of our surroundings. Stay clear of threatened ecosystems or protected heritage or cultural sites. We want to harness the sun's power, not disturb the natural balance. Picking the perfect site is just the beginning. Next comes the feasibility study. So, there you have it. The quest for the perfect solar farm location isn't an easy one, but it's certainly worth the effort. Remember, the sun is your best friend in this venture, but you also need to consider accessibility, terrain, soil conditions, and proximity to the grid. And of course, respect the environment around you. Choosing the right location is the first step on an exciting journey. So buckle up and let's get ready to harness the power of the sun. Once we have a site, we need to evaluate its economic viability, also known as a feasibility study. This crucial step involves a thorough examination of the site to determine if it's a viable choice for a solar farm project. The first component of a feasibility study is financial analysis. This process evaluates the costs and benefits of the project. It's not just about calculating the cost of materials, construction and maintenance, but also about estimating the potential revenue from selling the generated electricity. This analysis allows us to determine the return on investment and the payback period, ultimately helping us decide whether the project is economically feasible. Next, we delve into the technical analysis. This part of the study assesses the site's technical feasibility. It covers everything from the electrical infrastructure, soil conditions and topography. We need to ensure that the terrain is suitable for installing solar panels and other necessary equipment. The electrical infrastructure also needs to be capable of handling the power generated by the solar farm. Then, we need to take a close look at the environmental impact. Solar farms, while significantly less harmful than fossil fuel-based energy generation, can still impact local ecosystems and wildlife. This stage of the feasibility study identifies any potentially damaging effects and how to mitigate them. For instance, we might need to adjust the layout of the solar panels to avoid disrupting local bird populations or consider certain construction methods to minimize soil disruption. Feasibility studies are not a one-size-fits-all process. They need to be tailored to each site and project, taking into account a myriad of factors. It's a complex task, requiring expertise in renewable energy, finance, engineering and environmental science. But it's a necessary step, ensuring that the project is viable, sustainable and beneficial in the long run. With a positive feasibility study, we're ready for some market research. This next step will help us understand the local regulations, competition and demand, further solidifying the foundation for our solar farm project. But we'll delve into that in the next scene. A solid understanding of the local market is paramount for the success of a solar farm. This is where market research comes into play, a crucial step that cannot be overlooked. Delving into the local regulations and incentives is a must. Every region, every city, every state has its own set of rules, regulations and incentives when it comes to solar energy projects. Understanding these regulations is akin to deciphering a code that could unlock a wealth of benefits for the project. Are there any tax incentives, grants or rebates available? What are the local building codes and land use regulations? These are the kind of questions that need answering. Identifying competition is another essential aspect of market research. Who are the other players in the market? What are they offering and at what price? Understanding the competition is vital to carve out a niche, to differentiate and to ultimately succeed in the market. Gauging market demand is a bit like peering into a crystal ball. It's about assessing the current landscape and making informed predictions about future trends. How much solar energy is being consumed now, and what's the projected demand in the future? Is there a growing interest in renewable energy in the area? This information is crucial to ensure the solar farm can meet demand and remain profitable. Assessing grid connection possibilities is the final piece of the puzzle. Is there a nearby grid to connect to, or will a new connection need to be established? What are the costs involved, and how long will the process take? This step is vital to ensure that once the solar farm is up and running, the power it generates can be efficiently and reliably delivered to consumers. Market research, in essence, is about gathering as much information as possible to make informed decisions. It's about understanding the lay of the land, identifying opportunities, and foreseeing challenges. It's about ensuring the solar farm has the best possible chance of succeeding in a competitive and ever-evolving market. With our market research in hand, we're ready to start designing and engineering the solar farm. Now comes the exciting part, transforming our research into a tangible design. As we embark on the phase of design and engineering, we must keep in mind the physical and technical characteristics of the site. This is the stage where all the preliminary assessments, from site selection to feasibility studies, start to shape the blueprint of our solar farm. The design and engineering phase is a crucial step in solar farm development. It's akin to piecing together a complex jigsaw puzzle, where each piece is an essential element of the site. Whether it's the topography of the land, the soil conditions, or access to the grid, all these factors influence the design of the solar farm. An efficient design ensures the solar farm harnesses the maximum amount of solar energy. It's not just about placing panels in a field. It's about arranging them in a way that optimizes sunlight absorption. It's about considering the tilt and orientation of the panels, the positioning of inverters, and the layout of the electrical systems. The engineering aspect is equally vital. It's all about ensuring that the design is not just efficient, but also feasible and safe. This involves careful planning of the plant sizing and grid connection, taking into account the local climate, wind and snow loads, and the potential impact on the local ecosystem. The design must also meet grid interconnection requirements, ensuring the solar power quality is up to standard. This involves considering factors such as harmonics and power factors. And let's not forget the importance of budgetary considerations. The design and engineering phase must strike a balance between operational efficiency and cost-effectiveness. The ultimate goal is to create a solar farm that is not just environmentally friendly but also economically viable. In conclusion, the design and engineering phase is where the magic happens. It's where the vision of a solar farm turns into a concrete plan, ready to be brought to life. Designing a solar farm is a complex process. Next, we'll discuss some of the key components of this process. Choosing the right components is a critical part of the design process. When we talk about components, we're referring to the solar panels, inverters, and mounting and tracking systems that make up our solar farm. These pieces of the puzzle are what harness the sun's energy and transform it into usable electricity. So their selection is of paramount importance. Let's start with solar panels. Not all panels are created equal. Some are more efficient, some have a longer lifespan, and others are more cost-effective. It's a balancing act to find the right panel that meets the technical specifications of the project while also fitting within the budget. Next, we have the inverters. An inverter's job is to convert the direct current, DC, generated by the solar panels into alternating current, AC, which is used by most electrical appliances. There are different types of inverters to choose from, each with its own set of pros and cons. Some are more efficient, some are more durable, and others are more budget-friendly. It is crucial to choose an inverter that is compatible with the chosen solar panels and can handle the expected power output. Then there's the mounting and tracking systems. Mounting systems hold the panels in place, while tracking systems allow the panels to follow the sun across the sky for maximum solar exposure. These systems need to be robust to withstand weather conditions, and yet flexible enough to allow for optimal solar panel positioning. You see, selecting the right components is not just about picking the most expensive or the most advanced, it's about understanding the project's needs and constraints, and making informed decisions that balance performance, longevity and cost. Remember, every solar farm is unique. The components you choose for one project might not be the best fit for another. It's all about finding the right combination that will deliver the most efficient and effective solar energy production. With our components selected, we then need to determine the solar panel orientation. And that, my friends, is a topic for our next scene. Stay tuned. Opening. The orientation and tilt of the solar panels are critical factors in optimizing the system's energy production. Now let's get into the nitty-gritty. The orientation refers to the direction that the solar panels face. For most locations, the optimal orientation is true south, as this allows the panels to capture the most sunlight throughout the day. However, the ideal orientation can vary depending on the specific geographic location and the local climate. The tilt, on the other hand, is the angle at which the panels are set relative to the ground. The optimal tilt is determined by the site's latitude. For locations in the Northern Hemisphere, a rule of thumb is to set the tilt angle equal to the latitude. This ensures that the panels are angled towards the sun at an optimal degree for most of the year. But it's not only about latitude and direction. Climate also plays a significant role. In regions with high levels of snowfall, for instance, a steeper tilt can help the panels shed snow more effectively, ensuring they don't get buried under a white blanket. In contrast, in hot and arid climates, a flatter tilt can help reduce dust accumulation. Then there's the issue of shading. Shading can drastically reduce the energy output of solar panels, so it's crucial to take into account any potential obstructions that could cast a shadow over the panels. This includes nearby buildings, trees, and even mountain ranges. It's also worth considering that the sun's path changes throughout the year. Many solar farms therefore incorporate solar tracking systems which allow the panels to move with the sun, maintaining the optimal angle throughout the day and throughout the seasons. So, as you can see, finding the optimal orientation and tilt involves a delicate balancing act, taking into account a multitude of factors. But the payoff is worth it. With the right orientation and tilt, solar panels can capture the maximum amount of sunlight, leading to higher energy output and greater efficiency. Closing. Once our panels are perfectly oriented, it's time for the electrical and structural design. Opening. The electrical and structural design of the solar project involves careful planning and consideration. Let's dive right into it. The design phase is where things start to get technical. It's where the magic happens, turning the dream of a solar farm into a reality. It's no small feat, but with a little patience and a lot of meticulousness, the pieces start to fall into place. The electrical layout and plant sizing are crucial components of this design. It's not just about slapping some panels on a piece of land and hoping for the best. It's about understanding how the electricity generated by the panels will flow, how it will be stored, and how it will be integrated into the grid. We're talking about a complex network of cables, transformers, inverters and meters, all carefully planned and mapped out to ensure optimal efficiency and safety. But it doesn't stop there. The design must also take into account solar power quality considerations. This means looking at factors like harmonics and power factors. These technical terms might sound intimidating, but they're essentially about ensuring that the electricity produced is of a high quality, stable and suitable for feeding into the grid. It's about making sure that the power produced by the solar farm is reliable and consistent, day in and day out. And then there's the structural design. This is where we consider the physical stresses that the solar farm might face. We're talking about the impact of wind and snow loads on the panels, the stability of the mounting systems, and the resilience of the overall structure. It's about building something that's not just efficient, but also robust and durable. The structural design also takes into account the unique characteristics of the site. The type of soil, the slope of the land, the potential for seismic activity. These are all factors that need to be considered. It's about designing a solar farm that's tailored to its environment, able to withstand the challenges that Mother Nature might throw its way. In essence, the electrical and structural design of a solar project is a delicate balancing act. It's about marrying the technical requirements with the physical realities, all while keeping an eye on efficiency and cost-effectiveness. It's a complex process, but it's also an incredibly rewarding one. It's where the abstract becomes concrete, where ideas become reality. Closing, and there you have it. A glimpse into the complex process of designing and engineering a solar farm. Designing a solar farm is a complex yet rewarding process. From meticulously selecting the ideal site, conducting feasibility studies and thorough market research to crafting an effective design and engineering plan. Each step plays a critical role in the project's success. Component selection, solar panel orientation, and the intricacies of electrical and structural design are all vital elements. Next time you see a solar farm, you'll have a better understanding of the hard work and planning that went into its creation.